So now I'm having a little trouble getting on with the next lesson. The example is simple enough. In fact, it's too simple. I want to do something. You see, it's all to do with these interfaces and these classes that we talk about in COM. And sometimes, usually, you never need to know the, well, not usually. Well, maybe usually. Often you don't need to know anything about these class IDs. But there's certain COM objects that you have easy access to, and you can get bits and pieces out of them just by direct function call. However, one example of a COM object that you probably wouldn't expect to be COM, since it seems like a low-level thing, is this thing called DirectX, which you can download and install. Currently, in the year 2014, that won't be true next year. And I downloaded it, and now this is for direct access to video, direct 3D use, and so on. Is a separate thing that doesn't come bundled with something else that you can download separately. I know where did I put it. That's the problem. I must have put it in installers maybe. Here it is. I tried that you can. So there's on the Microsoft website. There's a link to the same file, and of course I tried. I clicked on it and started downloading, and then I went for supper. I come back and look at how's my download doing? Oh, network error. It was at, I think, 347 meg completed. Network error, so okay, give up. Try again. I didn't try again. Instead what I did was I used a program that I know has never, will never, and can never fail a download, ever. Ever. The only possibility is that it's not available for download. And that's this program called MuTorrent. And it's not just a program, it's a protocol. Many programs use the BitTorrent protocol for downloading and uploading, and it relies on peer-to-peer sharing. I have no idea where this file came from. It came from several computers. People have it. People know that not everybody in the world can survive a 600 megabyte download, without a hiccup. And so they need something that will, can solidly resume. And they, like me, don't want to install one of these download managers. And all a download manager is a sink for advertisements. So anyway, what I'm going to do, because I've used DirectX before, and that's for making computer games and things. And it's pretty cool because in a few lines you can create several of these COM objects, these interfaces, right? Instances of interfaces that'll do things But you couldn't do using GD, like the graphics device interface of Windows, in any reasonable length of time, because it goes directly to the hardware. It bundles the, if you remember our marshalling project, that thing, I don't know if I still have it. So I probably still do. We had this thing called pick view, right? And we bundled a bunch of routine, basically, passed it over to another component of our process in a different thread. It ran the code all in one go, and everything went nice and quick. Well, that's what your video card can do. On your video card is a small microprocessor. Actually, it's probably a 486 processor, but not because it's going to be doing mostly floating point operations. You wouldn't need the arithmetic unit, but I mean, you understand this. The world is made of things made by people, and people use the tools that they have available. And every year, into the trash bin go millions upon millions of microprocessors that could be used to do work. And a lot of the work that gets done on your system, my system, is being done and could be easily passed off to another processor. If you had another processor, this is a dual processor system already, but those processes are not completely independent. I mean, if suppose I had a big long job I wanted to get done, and I had a little, icon here, and I just dragged it into the icon, and then like this little chip here, and now it's running on a different processor, right? Like like this video encoder that won't allow me to double click. The reason why the double click doesn't work is because of it's because, according to Microsoft, oh look, it actually worked that one time. According to Microsoft, this encoder, WME, Windows Media Encoder, uses up so much processor resource that there's not enough time in order for it to accurately measure the time between the clicks, right? Now, if I could just set this thing to run on a different processor, then the double clicks should work, right? I could try. In fact, there is a setting to dedicate your one processor to one task. I could try doing that. But still, like I said, that would defeat the whole purpose of having a dual processor system, which is to allow for the pipelining to work properly. Maybe they have another solution for that, I don't know. So here it is anyway. The installer for the DirectX 8 SDK, I believe. And I'm going to install it on my C drive, not D. I install things like this programs go on C. These are data, or my programs, but and data. It's taking a while. There's no sense you sitting here watching it. I think with this and looking at the help file, I should be able to come up with a good intro into this so-called simple example. Okay. I'm too slow. I wanted, after it was installing, I realized I said DirectX 8 before, but no, this is at least version 10 or higher. It's the latest version. It's not some old version. This is the latest DirectX runtime, and I made a mistake in the initial install. I didn't install the symbol file, but I got the installer. I can add the symbol files. Symbol files just lets you see more easily see a stack trace of in a debug mode of what's calling what. Okay. Well, while I'm adding addendums, I might as well show you that it did succeed with three failed installs. The fourth install succeeded, and that failure for the latest version of the DirectX software development kit, which I also change this. General items, yes. Apply to everything. What do I have? That's not general item. That's pictures. Wait a minute now. It is applying. It's just taking its time. Okay. There's a lot of stuff in here, including sound, of course. Sound is part of DirectX. Now you might wonder why there'd be a directory called debug. Well, because this is the debug for your debug build. That's the DLL that you use. It's got symbols in it. You know, it's like there's a PDB file or something. Debug. And even for retail. DLL. Here's dsound PDB. See what I'm saying? Now, I already have a compiler installed. So that means it should have integrated it auto-magically, and I don't trust it to do that correctly, but it says it did. It says it said installing Visual C++ components or something, which would mean it'll give extra project options, and it'll try to guess certain things automatically. But let's just see if it. Okay, let's see if the thing still runs first. But to make a simple a simple project that uses Direct 3D is really nothing to it. The question is, what happened to the help documentation? It said it was adding it to the help documentation. So I should have a new type of, section in the help hint file, the help of hint file, pertaining to DirectX. And while that's loading up, we're going to have a more of a look at what's in this folder. It's always for me been under C MSSDK. Why? I don't know. But I'm used to it being there, and it's good that it's not under program files. If I wanted to, I could give it the same properties as safeties as program files have. But I like the fact that there's no, this has a space in it and this doesn't. Okay. Now, unfortunately, this directory does, but most of these directories don't contain spaces, and so you're much less likely to go wrong with spaces. Spaces are the bane and the hell of our lives. As developers, spaces, general items, everything. Fine. Okay. Now, let's just look here and see. Well, actually, the header files are what we want to see, right? Include. These are inline. These are meant to be compiled inline. D3DX10 math. So these are inline mathematics utilities. There's one for DirectX 9. I remember it being there. Vector, so vector math is inline. That means that what an inline is, if it really does, I don't know if it does. Inline code simply means that what you declare as a function is more like a macro. You know, it's this calculation here. Something splats. Does this and then returns that, right? If this is inline, every time you call this function, it's simply the compiler just dumps the code at that location instead of invoking a function call. So that speeds things up, and there's no push BP, move into BPSP, and all that stuff. If it works, inlining doesn't always work, so, but whatever. Now you'll notice there's D3D version 9. There's D2D, that's direct to 2D DirectX, okay, now DirectX has been around for years and years, but it still supports it, the current version still supports it. And it has to, if it wants to be, it's part of the COM spec actually forces this conformance, this compliance. Because of COM, and because this interface is referred through by the same identifiers as DirectX, like it's using something called COM inheritance, which is not C++ inheritance. It's a different kind of inheritance. It's the kind of inheritance that would be like inheriting a debt rather than inheriting like if your daddy died in debt, you wouldn't want the inheritance, right? That's COM inheritance. If your daddy died with lots of money, then you would want the inheritance. You'd want to collect what he had. That's C++ inheritance. But this is not that. So therefore, all these things need to be implemented in this as well. And furthermore, even version 7 ought to be in here somewhere. Oh, now we're up to version 11. DX10. Yeah, there's version 11 now. I wonder what's new in version 11. Well, not much in the header file. This keyword is a lie, it doesn't work. Direct input is down there. And I'm just wasting time unless I find something of genuine interest to look at. D sound maybe. Okay, here. See these things? These are the class IDs. Okay, now I guess you don't realize, but I've been struggling to try and find some classes because COM has to do with classes and interfaces, right? And to get an interface to one of those, like in my example, to get an implementation of an interface, you need two things. You need a class ID and an interface ID. But usually, you don't know the class IDs. That part is hidden away from you, but not with direct sound, see? Here, there's all sorts of classes we can use. Okay, now underneath each of these classes, we'll have some interfaces. Now, direct sound aid. It's a structure in all pure virtual functions. And then, now these are interfaces. Now, because I know they're interfaces, these refer to interfaces, okay? Now what is this saying? Define 8 as capture. So if I say capture, I really mean 8. Okay, that's right, that's correct. So normally, let's say you want to play a song, or play a distortion or something, then you get one of these interfaces. You get an interface to a sound effects distortion object that does something or other, and so on. Now there's a bunch of structs and stuff. And we can use this all now because I've installed the SDK. And the documentation ought to be in here. DirectX SDK, there it is. Audio, input, games, programming guide, getting started, games explorer. Oh, I don't know about that. That's probably, there's probably a new thing. Games explorer, you can just imagine what that is. SDK is the interesting part. Now there's 2D and there's 3D. And I would only want to do something in 2D. It'll go there, just my help things messed up. But some of the things that, here's an example, my own example actually. When I used to make games, we had called the graphics kernel, our graphics engine, 2D graphics engine, which used initially a simple access to the actual video memory, which you can read from and write to and so on. That allows you to do blurring and alpha blending and so on, but it's very slow. With D3D, it's not slow because the hardware handles that. Now, this here test here, what it does is it's just, I'm applying, when I hit space, it's going to drop, it's going to create some balls, and they're going to fall down, and all I've got going are the laws of physics and a constant gravitational downward force. And what I'm computing every now and again is total energy of my system, assuming all of the balls are the same mass. So in units of whatever that is. Here are the balls. Now, I wrote this as a unit test, and I was curious as to why it was that the energy, this, it's choppy now because of the recorder, but you'll notice it'll run through even the frames you don't see them. The time got lost. This number kept going down. I would lose energy. I was always losing more and more energy. Was I losing or gaining? No, definitely losing. Right? Now that contradicts the laws of physics, I thought. And I looked a little bit closer at our game engine. And we had something, this is a good puzzle for you for next time. I studied physics, so it wasn't too hard for me to find this bug, but let's see, where can I write anything? So all the objects in the game were called sprites. So they'd be like class sprite, right? And it has a bunch of virtual functions. One of them is called update, let's say, and you gotta fill that one in. You have to update yourself, and the updates happen at regular intervals. Okay, assuming that they happen at regular intervals. But now it wasn't completely purely virtual. There are some things that it maintains on its own. Let's say X pause, right? And Y pause, members, and velocity is maintained. And this part was actually done internally. X val, Y val, right? Also acceleration, X acceleration. So here we got all the ingredients for Newtonian physics. We got position, velocity, and acceleration, right? Now, in the case of the gravity thing, acceleration, X acceleration is 0 and Y is constant, 9.8 something. Okay. And actually I lied. Part of the update, well, maybe it might not have been called update, but maybe there was maybe this was true. But there was also a non-virtual function called update position. Okay, given the current state. We went something like this. Let's see now. MVX pause would be plus added to that would be our current velocity times the amount of time that it elapsed, right? So now we know that's a constant value because our updates happen at regular intervals. So we'll call that, I suppose that's a constant. Frames per second. Okay. Now, if velocity is in pixels per second, right? So we have to divide by frames per second. Now this gives us pixels per frame, right? It's one frame, so that's how far we would move in one frame. Is that correct? Something like that. Right? So, oh no, that's a ratio still. Pixels per second divided by frames per second is pixels per, yeah, but the number of frames is 1 implicitly here. Right, so there's a times 1 frame. Now you'd have, so to get this right, you'd have to call this every frame. Okay, now if there's an acceleration, now I didn't write this code, by the way, it was already there, and it looks pretty right. Our velocity might be changing if there's an acceleration, right? And also divided by the same constant. So our velocity increasing or decreasing does that, right? And is that it? So our position changed, and then our current velocity got updated, and so you could call this that given the current acceleration. Now it's possible the acceleration may be changing too. So you could add, if you want to be really clever, you could add the possibility of the acceleration changing. Now what are we going to multiply this by? Well, we would need another variable. Thrust. So you could have a changing acceleration, and that in the lingo of physics is called thrust, the rate of change of acceleration per unit time. But actually, let's just take that out. We didn't have thrust, and nobody does. Okay, now for a fixed or constant acceleration, I'm telling you right now that this calculation is incorrect, and your puzzle is to correct this calculation for correctly updating the position and velocity after 1 unit of time has elapsed. Okay, see you.